students, welcome back. I am Rikesh sir. Today we are going to continue with exercise 9.2 of chapter number 9, that is differential equations. Till now we have completed till question number 4. Let's start with question 5. Question number 5. You have to prove that y equal to ax is the solution of differential equation xy dash equal to y. We will start with y is equal to ax. So differentiating with respect to x, y dash will be equal to a. Clear? Now if I name this equation as 1, then from that I can write down a equal to y by x. So y dash will be equal to y by x. Okay. So by this way I have removed the constant a. This is from 1. So what does this mean? X y dash equal to 5. Okay, so this was about question number 5. Just note it down. Now let's move to the next. That is question number 6. Question number 6. Y is equal to x sine x. And you have to prove this is the solution of xy dash equal to y plus x under root of x square minus y square. Okay, so now differentiating with respect to x, derivative of y is y dash equal to x as it is, derivative of sin x is cos x, plus sin x as it is, derivative of x is 1. Okay, now see, in the differential equation I neither want sin x nor cos x, so I can replace it from equation 1. Okay, sin x I can replace it as y by x. Okay, sin x will be equal to y by x, but cos x is not given. So what I will do first, I will convert cos into sine. Root of 1 minus sine square x, right? 1 minus sine square x is cos square x and its square root plus sine x. Now what I will do, instead of root of 1 minus sine square x, instead of sine x I will use y by x, so y square upon x square plus and sine x y by x, so y dash will be equal to x into square root of, I will take here LCM, so x square minus y square upon x square plus y by x. So again y dash will be equal to x into root of x square minus y square upon x square and square root. So it will be equal to x plus y by x. Now let's add this. In both this case denominator is x, so x as it is, so it will be x into square root of x square, sorry it's not x square, it's y square, x square minus y square plus y. Taking x on this side, I will get x y dash. We're writing this y first, plus x into square root of x square minus y square. Okay, so this was about question number 6. What we did, first we differentiated with respect to x. We saw that in differential equation we neither want cos nor sine, so I tried to replace it from equation 1. First I replaced cos in terms of sine, and then I took value of sin x as y by x. Then rearranging I got the final answer. Okay, hence the given solution is for the given differential equation. This was about question number 6. So just note it down. Now let's move to the next question. Question number 7. Xy equal to log y plus c. You have to prove this is the solution of differential equation y dash equal to y square upon 1 minus xy. Xy is equal to log y plus c. We use the usual method differentiating with respect to x. I will get, now I will use here method of uv. So x as it is, derivative of y is y1 plus y as it is, derivative of x is 1. Log y, I will write down 1 by y into d by dx of y, that is y1. Derivative of c is 0. Okay, so x y1, I will take this on the other side, minus y1 by y is equal to minus y. I took this y on this side. Now taking LCM, x y y1 minus y1 upon y is equal to minus y. So in numerator I can take y1 common. So xy minus 1. Now taking y on the other side, it will be minus y square. So y1 will be equal to minus y square upon xy minus 1, or taking negative sign common, numerator I will take y square, in denominator instead of xy minus 1, 1 minus xy. Okay, so hence we had proved that xy equal to log y plus c is the solution of the differential equation y dash equal to y square upon 1 minus xy. Okay, so this was about question number 7. So just note it down. Now let's move to the next, that is question number 8. Question number 8. Y minus cos y equal to x. You have to prove that this is the solution of differential equation y sin y plus cos y plus x into y dash equal to y. Okay, so now let's differentiate with respect to x. Derivative of y is y dash minus derivative of cos y into d by dx of y, y dash. Sorry, mistake. Derivative of cos y is minus sin y. So this will be plus sin y into d by dx of y, y dash. Derivative of x will be equal to 1. Okay, so y dash I will take common, 1 plus sin y is equal to 1. So y dash will be equal to 1 upon 1 plus sin y. But now in the given differential equation, okay, we require to prove this LHS y sin y dash plus cos y plus x into y dash equal to y. Now we need to prove this is equal to y. So what I will do, cos y, okay, from equation 1 I can write down cos y is equal to y minus x. So I will replace this cos y. Now remaining is sin y. So from, let's say, equation 2 I can replace sin y as 1 minus y dash by y dash, right? Because sin y into y dash will be 1 minus y dash divided by y dash. So now replacing this value in LHS, y sin y plus cos y plus x into y dash. Now, instead of sin y, I will put 1 minus y dash by y plus, instead of cos y, I will put y minus x, and this is plus x. Y dash x gets cancelled. Let's take LCM. Y into 1 minus y dash plus, sorry, this is y dash. Y into y dash upon y dash into y dash. Y dash gets cancelled. Now let's multiply y into 1, y minus y into y dash plus y into y dash. So this will get cancelled, equal to y, and that is equal to RHS. Okay. Hence y sin y plus cos y plus x into y dash equal to y is the differential equation whose solution is y minus cos y is equal to x. This was about question number 8. So just note it down. Now let's move to the next question. And question number 9, you have to prove that x plus y equal to tan inverse y is the difference solution of the differential equation x square y dash plus y square plus 1 equal to 0. X plus y equal to tan inverse y. So differentiating with respect to x, derivative of x is 1, derivative of y is y dash. Derivative of tan inverse y, 1 upon 1 plus y square into d by dx of y, that is y dash. Okay, so now it's 1 plus y dash equal to y dash upon 1 plus y square. So 1 plus y dash plus y dash upon 1 plus y square is equal to 0. I can take y dash common here, or else let's take LCM. 1 plus y square into 1, 1 plus y square. 1 plus y square into y dash, 1 into y dash plus y square in, sorry, and this will be minus, not plus, y square and plus y dash y square minus y dash equal to 0. Y dash gets cancelled, and when it goes on other side it becomes 0. So 1 plus y dash equal to 0, or rearranging y square y dash plus y square plus 1 is equal to 0. Okay, so hence we had proved it. So this was about question number 9, so just note it down. Now let's move to the next question. Question number 10. You have to prove that y equal to square root of a square minus x square is the different solution of the differential equation x plus y dy by dx equal to 0. Y is equal to under root of a square minus x square. Differentiating with respect to x, derivative of y is y dash. Now derivative of root x is 1 by 2 root x. So derivative of root of 1 upon, root of e square minus x square will be 1 upon root of e square minus x square 2 root a square minus x square into d by dx of e square minus x square minus 2x. So now y dash will be equal to, first 2 gets cancelled, x upon square root of a square minus x square. I can put it down as y. Okay, so y, and it's minus. So y dash plus x by y is equal to 0. Taking LCM, y dash plus x equal to 0, or else rearranging x plus y. Instead of y dash, I will write down dy by dx equal to 0. Okay, hence we had proved it. This was about question number 10. So just note it down. Now let's move to the next questions, 11th and 12th, which are the last two for this exercise, which are MCQs. Question number 11. The number of arbitrary constant in general solution of differential equation of fourth order. Now see, it is of fourth order means 4 times derivative have been taken. That means there will be 4 constant. If it is second order, 2 constant. Third order, 3 constant. So number of constant in general solution is equal to the number of order. Means nth, if nth order is there, then n number of constant. So as it is fourth order, so 4 constant. Question number 12. The number of arbitrary constant in particular solution of differential equation of third order. Now see, whenever there is particular solution, that means there will be no constant. Whether it is first order, second, third, or whichever order it is, in particular solution, there will be no constant. The constant will be only present in general solution. So in particular solution, the number of constants are 0. Okay, so this was about question 11th and 12th. Okay, students, so that's it for today. Here we have completed exercise 9.2.